If you buy a normal TV, your biggest logistical problem is usually just, fitting it in the back of your SUV.
Right, just hoping the trunk actually closes.
Exactly. But today, we're looking at a screen so massive, I mean, it's 18 feet wide, that just getting it into the building is a feat of architectural engineering.
It really is wild.
So welcome to this custom deep dive. Our mission today is to explore the hidden engineering and logistics of massive professional-grade visual displays. And for this, we're using a spec sheet from HDTVSupply for the Draper 254-257 profile plus fixed frame screen.
Which is quite the mouthful.
Oh, yeah, it is. Okay, let's unpack this. We are talking about a 255-inch diagonal display that costs over $7,500. Our goal today is to uncover how an object this massive actually functions out in the real world.
Because before anyone can sit down and watch this screen, you have to solve a fundamental physics problem, right?
Yeah.
It has to physically enter the room.
Right, because a 255-inch diagonal is 216 inches wide. That is roughly the size of a delivery truck.
Yeah, a pretty big one.
Right, so if you're outfitting a corporate training room or a church, you can't just knock down a load-bearing wall to bring the display inside.
Well, what's fascinating here is the logistical engineering behind it. The manufacturer doesn't just ship an 18-foot rectangle.
Right, that would be impossible.
Exactly. The source notes this screen is designed with a lightweight aluminum frame that ships entirely unassembled.
Oh, wow.
Yeah, so by breaking it down, installation crews can easily maneuver the product up tight stairwells. They squeeze it into standard elevators, navigate narrow corridors.
I mean, think about the struggle of pivoting a standard 3-seat couch up a flight of stairs.
It's a total nightmare.
It is. Now imagine setting up an 18-foot optical surface. The brilliant part is their sliding hook and loop system.
Right, instead of wrestling a giant pre-stretched canvas.
Yeah, a 2-person crew builds the metal frame right there in the room, then uses this sliding system to apply hundreds of pounds of even tension across the canvas.
Which pulls the material perfectly flat.
Drum tight, yeah, and without warping the frame.
So that solves the physical delivery beautifully. But the next hurdle is ensuring that, 21-foot viewing area actually looks seamless and high quality once the projector turns on.
And looking at the specs, I actually have to push back a bit on the materials they chose.
Oh, really? Why?
Well, the sheet specifies a gray XH600V surface with a 0.6 gain, paired with complex extruded aluminum baffles.
Right, the baffles.
Yeah, why go through all that trouble with gray fabric and aluminum instead of just projecting onto a giant flat white wall?
Well, a white wall reflects light entirely unpredictably. That 0.6 gain on the gray surface is a very specific optical choice.
Because of the ambient light?
Exactly. In a brightly lit corporate room or a church with giant windows, a white screen would just wash out the image entirely.
Oh, I see.
Yeah, the lower gain gray material absorbs that ambient room light, which preserves deep black levels and sharp contrast so the presentation remains legible.
Okay, here's where it gets really interesting, though. To make that gray canvas look like a crisp, floating image rather than a framed poster, you need those extruded aluminum baffles.
The ones you mentioned earlier.
Yeah. They provide the extreme structural rigidity required to hold that massive canvas perfectly square under all that tension.
And it does that without needing a thick, visible outer border holding it all together.
Right.
And that invisible border is what the text calls the zero-edge option.
Zero edge.
Yeah, and because it's borderless, it unlocks a mullion-less capability.
Wait, what's a mullion?
A mullion is that vertical dividing bar you usually see between tiled screens or windows.
Oh, right, like a grid.
Exactly. Without a bezel getting in the way, you can stitch multiple adjacent screens together with absolute zero separation.
So you transform it from a functional display into a completely seamless architectural feature.
Precisely. It's an entirely different league of spatial problem solving and optical design.
So what does this all mean for you, the listener? The next time you are sitting in a massive corporate presentation or a large church, take a closer look at the display.
Yeah, you are likely looking at a meticulously tensioned, site-assembled optical instrument.
Not just a big TV. Which leaves me with one final thought. If we can seamlessly tile these massive, mullionless, borderless frames side by side indefinitely, at what point does the screen stop being an object hanging on a wall and start becoming the wall itself?